Let's start with our first sample problem. We have here a water tank having a mass M supported by four steel columns. So take note of these four steel columns with a collective stiffness K, Young's modulus C, length L, and structural damping C. We are asked to find the natural angular frequency, C omega, damping ratio, C psi, displacement U at time is equal to 5 seconds, and then the response velocity V at time is equal to 5 seconds. So we have given here dc is equal to 0, the elasticity is equal to 200 GPa, the inertia 178,645.883 millimeter to the fourth, and then we have the length na 3,500 millimeters and the mass na 5,000 kilograms. So first, let's draw the system no, para mas masabtan ninyo. We have a single degree of freedom system here. So take note that this is a rigid mass, M. And then we have our columns here. Its height is L is equal to 3,500 millimeters. So this is in 2D, no? The ingon niya din nga 4 steel columns, this is in 2-dimensional. What else? So first is, ang first ginamibuatan is to determine if unsa yung type of free vibration, is it undamped or undamped. But klaro kayo that C is equal to 0, therefore this is undamped. Now, gipangitan taog natural angular frequency. So the natural angular frequency is just equal to K equivalent over the M. Pero wala pa man tayo K equivalent, we solve first the K equivalent. So take note that this is the system na the supports are in fixed, these are fixed connection. So, unsa man lugar kung fixed connection? Our K stiffness is equal to 12 EI over L cube. So our EI, we just take the first the value of EI. So our E, the Young's modulus, that is 200 gigapascal or 200 times 10 to the 9 Newton per square meter. And then our I, or the inertia, moment of inertia, is equal to 178,645.833 millimeter to the fourth. Now it is important to take note of the units. Here we have the Newton per square meter and then dili naka millimeter. So aron na unity of ratio, we convert this millimeter into meter. Since wala may indicate diya kung saan unit atong gamiton, sa ato pa convert na to tanan into SI nga into meter. So the millimeter, we know that the 1 meter is equal to 1,000 millimeters. Since the millimeter is to in fourth power, then we raise this part here into the fourth power. And eventually, we will have our EI is equal to 35,729.1666 Newton square meter. So our stiffness K here, we have the 12 times 35,729.1666 Newton square meter over the length 3,500 millimeter. So this is in millimeter, so we just convert this into meter, and we know that 1,000 millimeter, there is a 1,000 millimeter per 1 meter. Then we raise that to cube. Then eventually we will have our K equal to, that is approximately equal to 10,000. Don't forget about the units. This is in Newton per meter. So we already have our K. K is equal to 10,000 Newton per meter. Next, we can get our omega, which is equal to the square root of K over M. So this is our collective stiffness, K, 10,000 Newton per meter. So first one, pakibalo nga collective stiffness or individual stiffness. So kanila siya no, kalam ko indicate that this is a collective inertia na sad. So this is for the 4 sections. So that is just equal to square root of 10,000 Newton per meter divided by 5,000 kilograms. So importante no nga ang numerator dapat naka Newton per meter and then ang denominator is naka kilograms. Because kung ato nang bungkag si Newton per meter, that is Newton is kilogram meters per second squared and then divided by meter pag na because Newton meter over 5,000 kilograms. So makansel na to si kilograms, makansel si meter, and then ang mabilin is just si per second squared. So we will have that the omega is just equal to square root of 2 radians per seconds. So na natin answer sa to ang A. Or this is omega is approximately equal to 1.4142 radians per seconds. Next is the damping ratio. Si damping ratio psi is equal to C over 2m omega. But since here there is no damping, then our damping ratio is just equal to 0. What else? Displacement U. Okay. So earlier no, since this is an undamped, and this is in undamped condition, diba na ko atas inyo nga para dali na gid kay dumdumon nga formula. U is equal to alpha cosine omega t plus beta sine omega t. Since balik-balik man nga term no si omega t. So ingon niya at time is equal to 5 seconds. So ato na lang na siyang kuan diretso. Our omega t is equal to, so if you recall, our omega is 1.4142 radians per seconds. Then times 5 seconds, our omega t is equal to 7.071 radians. So we'll have that U is equal to alpha cosine ato na sa na E omega t plus B, yeah. Balik na akong sulat. This U is just the derivative of velocity. So alpha cosine omega t is just equal to negative alpha omega sine omega t plus here we have the beta omega times cosine omega t. So I forgot to include here the initial displacement U naught is equal to negative 400 millimeters, and then our velocity, initial velocity is equal to 300 millimeters per seconds. So don't forget not to write the unit because this is it has a magnitude and also a direction. Now to solve this, no, at time is equal to 0, our U is equal to this one. So at time is equal to 0, initial position is at negative 400 millimeters, and the velocity is equal to 300 millimeters per seconds. So asa gikan ni si U naught o si V naught, this is given. So at this time, so this one no kani si U, this will become negative 400 is equal to alpha cosine, and then our omega t, that is 0, plus beta sine 0. Don't forget no to set your calculator in radians mode. Kaya angle nga yung gigamit diri, if you notice, this is in radians, that is not in degrees. So here, since cosine of 0 is 1 and sine of 0 is 0. So we already have our alpha, which is equal to negative 400. How about our beta? So we use this equation. So we have here initial velocity 300 is equal to negative alpha omega sine omega t. So our omega t for this one is 0 because we try to consider the values at time is equal to 0. So we have a sine 0 plus beta omega cosine 0. So again, note this part here that is 0. And then we are left with beta omega. So our cosine 0, that is just 1. So we have 300 is equal to beta omega, or beta is equal to 300 over omega. Our omega, or the natural angular frequency, is equal to 1.4142. Therefore, our beta, which is equal to 300 over 4142, becomes 212.1341. So you have your alpha and your beta. So we just substitute this to the your general equation of motion. So you have again u is equal to alpha cosine omega t plus beta sine omega t, and you have so you just substitute the value of alpha. Alpha is negative 400, beta is 212 point, we have the 1341. Omega t is, just take note again with this one, or omega t is equal to 7.071. 7.071. So we have a negative 400 cosine omega t plus 212.1341 sine omega t. So at time is equal to 5 seconds, you have that u is equal to negative 400 cosine of 7.071 plus 212.1341 sine 7.071. So your position at time is equal to 5 seconds is just equal to negative 131.7949 millimeters. Sir, yung sa man na pagkaibalo nga millimeters ang unit, dili meters. Or unsa nga unit ang gigamit. So may bala na nimo by this by your initial conditions, no? If imong gigamit diri is in millimeters, of course, millimeters imong makuha diri. If the condition naka meters, then naka meters pwede siya diri. Since if just in case if naka meters ni diri, dapat imo pong velocity instead ng millimeters per second, imo convert po na nimo into meters per seconds para na ay consistency and unity sa ato ang result. So we have our u, or our displacement. Now let's solve the response velocity when time is equal to 5 seconds. So our velocity, diba, is equal to negative alpha omega sine omega t plus beta omega cosine omega t. So the alpha is equal to negative 400, negative of a negative 400, so that is a negative of a negative 400, and then our omega is 1.4142 sine of 7.071 plus 212.1341 times 1.4142 cosine of 7.071. So eventually we will have a velocity equal to 612.5804 millimeters per seconds. So be careful with your units, ha? Be consistent with your units aron wala mo type sa inyo ang answer. So muna siya number one nga condition nga yung observe is that units should be consistent and that so for this one no your calculator should be in radians mode. So this is a first example for our a undamped no. So the damping here is there is no damping here as c is equal to 0. So our u or the lateral displacement at time is equal to 5 seconds is just this one and our velocity is this one.